are digital twins? How do they work? And what is the future of this technology? I'm Asma Lapouche, Product Marketing Manager at Ansys. This first Twin Talk episode will feature Samir Kher, Senior Director, Product Development at Ansys. Samir is responsible for digital twin and system simulation activities. Most recently, he was responsible for the conception and launch of Twin Builder, an award-winning product that enables the use of simulation and operations. He has a background in engineering with a Bachelor of Science in Electronics from the University of Pune, a Master of Science in Computer Engineering from the University of Cincinnati, and an MBA from Carnegie Mellon University. We are going to discuss the concept of creating a digital replica of a physical object, system, or process, and explain how Ansys is shaping the digital twin landscape. Samir, let's start with the fundamentals of digital twins. Can you give us a comprehensive overview of what digital twins are, what they aren't, and how they work?
Sure. Thanks, Asma. So really quickly, while the concept of digital twins has been around for a long time, it's really only recently, so like in the last 5 years or so, that the evolution of key technology building blocks has happened. So things like IoT, machine learning, compute, and that's really allowed digital twins to become a reality. We at Ansys and a lot of our customers define digital twins as virtual representations or models of real-world entities like equipment or processes. And there is a synchronization between the real world and this virtual model. This communication aspect is really key because this is what lets this virtual model experience whatever the real equipment or process is actually experiencing and truly makes it a digital twin. The digital twin that you built then allows you really to track the past, get deeper insights into the present behavior of your equipment or process, and then probably most importantly, predict and influence future behavior. Our customers use digital twins to improve both their top line and bottom line, offering new models through service offerings and helping improve profitability, improving their maintenance and service costs, and helping their bottom line, as well as really using digital twins as a competitive differentiator.
What do you think is the most common misconception about digital twin technologies?
Yeah, so most organizations tend to start with the assumption that a predictive digital twin can be built using just data or just database models alone. And that's not necessarily a bad place to start, but it is definitely a misconception. We also have others, or we've seen others, that really just think they can build a digital twin purely based on first principles or physics models alone. In reality, what we find is a good, accurate digital twin really combines both of these approaches into something we've defined as a hybrid approach. Domain knowledge that comes from things like physics and simulation-based modeling, clean data, and then most importantly, getting failure mode data. All of these are really critical to creating a good digital twin. So using the combination of physics-based models, which incorporate that domain knowledge, and then database models that incorporate all the data and sensor information, really allows the model to evolve, and this leads to the most effective digital twins.
Digital twins have proven to be transformative across various industries. Could you share some examples of how this technology has made a substantial impact to some customers?
Yeah, certainly. And this is one of my favorite topics. As we at Ansys have rolled out our digital twin solution, we've really been fortunate and had the opportunity to work with some of the best and most forward-thinking organizations. We put out public stories and public references regularly. One recent example that's public is with Tata Steel, which as several of us may know, is a global steel manufacturer. A key challenge for steel manufacturers and for Tata Steel is in the transportation of hot metal within a manufacturing facility. So higher hot metal temperatures really help improve the yield when you're transporting it, as well as lower the carbon dioxide emissions. But obviously with the higher temperature, it causes higher wear of the equipment that's used to transport, as well as requiring higher energy usage. And so what we've been able to help them build using our technology is really a very detailed digital twin of the transportation equipment and the material and the lining, and that really lets Tata Steel understand and optimize for the wear that the equipment has to undergo versus the yield and emission trade-off that they want to do. Ultimately, they've really been able to use our digital twin technology and are kind of deploying it right now in several facilities, but they're able to use it to lower their maintenance costs and downtime while still meeting their sustainability targets. So, this is a really, really exciting use case. There's other use cases that we put out. So, definitely, uh, you know, follow us on the LinkedIn channel, and there's other avenues that we'll put out our public stories going forward.
And Samir, what technology or improvements are incorporated into Ansys digital twin products? And how does AI ML incorporate into it?
Yeah, so we've had our digital twin offering on the market since about 2018. We've added several key product innovations to the product. The ones that and you can find more if you look online. The main ones I do want to highlight that are significant differentiators, I think, and big value adds are as follows. The first is reduced auto modeling. So, one of the things we really want to help customers do is to unlock all of this engineering knowledge that they already have when they built and designed the product. And typically, this knowledge is codified as simulation models. And we want to help them bring that to bear in the context of operations. And we do that through reduced order models, which is essentially a set of numerical techniques that let you take high fidelity simulations that typically tend to take hours or days to simulate, things like CFD or mechanical, and convert that into a form that can be used, can be executed real time, and then it becomes relevant for operations. So that's one, reduced order modeling. The second I mentioned earlier is hybrid analytics, and that's really being able to take data and combine data with physics. And we have several techniques there that we've brought to market. And really that leads to much more higher accuracy because you can now customize your twin to the actual operating conditions. And it also leads to a twin that can evolve over time. So as the equipment wears or is used differently in different operating conditions, the digital twin model will also sort of evolve appropriately. So that's number two, hybrid analytics. And then the third key capability I talk about is deployment and scaling. So we have a mechanism that really lets you take your digital twin model and then scale it easily. We use APIs, published APIs, and we use container technology as well as the ability to create Python scaffolding code as well as browser-based scaffolding code that really we think makes it easy for customers to scale these digital twin models, as they need to monitor additional equipment. So those I would say are the big areas of technology. AI/ML obviously is incorporated significantly in both the reduced order modeling technologies I mentioned as well as in hybrid analytics.
Thank you, Samir. Looking ahead, what do you see as the future potential and challenges of digital twin technology in the coming years?
Yeah, so we do see a lot of interest from a lot of customers in this technology. I would still describe it as being in a relatively early stage. This interest is increasing, and we see more customers starting to deploy, and we do expect this market to really grow over the long term. And so, while it's relatively small today, we do expect it to be significant and more meaningful in the long term. In terms of challenges that potentially maybe limit, there is obviously all of the infrastructure costs that customers have to go through in order to build. But once they've got that done, the next steps tend to be a lot easier and tend to unlock a lot more potential. Some of the work that we're doing in the Digital Twin Consortium and in other forums to help standardize and to make APIs sort of well defined and interoperable, we think that's really going to help improve and increase adoption going forward.
It's fascinating to see how digital twin technology has evolved over the years. Thank you so much, Samir, for being part of this first episode of the Twin Talks and for sharing your invaluable insights and expertise. In the next episode, we are going to explore the diverse range of applications and use cases for digital twins across industries. So stay tuned for episode 2 of the Twin Talks. Thanks for watching.